Hey guys, this is the Integrated Science Unit 3. We are in the Chemistry unit, and this is Skill 3, Phases of Matter. So today we're going to talk about how the same type of matter can convert between different phases, solid, liquid, and gas. So when you're going through the three different types of matter, solid, liquid, and gas, sometimes it's easy to conceptualize water because you're familiar with it in three states of matter. You have the solid ice cube, the liquid water that you drink, and the gas phase of water like steam. Like if you take a really hot shower, not the water that's hitting you, but the steam right outside that's kind of like that misty stuff, that's going to be water vapor. So let's talk about properties. For a solid, that's going to be matter with a definite shape and definite volume. And by definite, I mean not changing. So like I have this book here, that's obviously a solid. And no matter what I do, whether I hold it up here or if I put it on a table or if I throw it in the air, it still has the same shape as the book has. So it's a definite or defined or not changing shape. The volume is talking about how much space it takes up, and it's not going to change how much space it takes up. Like if I pick the book up in the air, it doesn't make it a bigger book. All right, liquid. So think about liquid water. It has an indefinite shape. So if I take that liquid water and I pour it on the ground, it's not going to keep the shape of the cup. It's going to spread out to whatever it's on or in. But it does have a definite volume. If I have 1 liter of water, it doesn't matter if I have it in a cup or if I spill it on the ground or if I throw it up in the air, it's always going to be 1 liter of water. But then there's a gas. And the gas has an indefinite shape and an indefinite volume. So both of those are indefinite or undefined or takes whatever its container is. So if I have air in my lungs, right? That's a gas. And if I blow into a balloon, it's going to take whatever that shape of the balloon is. Have you ever blown up a balloon and it actually is like a Mickey Mouse with ears? Well, the air in your lungs wasn't shaped like a Mickey Mouse with ears, some crazy looking balloon. It's shaped like your lungs. So whatever container it's in, that's the shape of the container. It also has an indefinite volume, meaning gas can expand or contrast based on whatever you put it in. So you can have a highly pressurized system by having a lot of gas put into a small area, like a pressure cooker has a lot of gas all in one area. Or you could let something expand, and if you let a gas take over a large area, it'll just go through whatever, go to the outer limits of whatever container you put it in. So one thing to know is liquids and gases are both considered fluids. So that's because they literally can flow or you can pass through them easily versus a solid isn't going to flow anywhere, right? If you try and go through a solid, it stops. All right, so let's look at this, and this is going to go over the states of matter. So right now, I'm looking at oxygen, and if you want to go to this, it's a PhET lab. You can look it up online. You can play with the different molecules, but I'm just going to do oxygen for now. So look at how oxygen is when it is a solid. So I've clicked solid. Look at the temperature. It's at 31 kelvins. It's really cold. Oxygen can be a solid at super, super, super cold temperatures. If I make it a liquid, look what happens to the atoms. They start separating, they start going over here, they're about to take the shape of their container, versus that solid, it was all rigid, right? So I'm going to heat it up a little bit, and they would spread out. Oxygen does not stay a liquid very long. So see how it's starting to come up? That is because it's starting to become a gas. If I increase the temperature by adding this heat, it's actually becoming more of a gas. I'm going to click gas so it goes to it faster. And look, the temperature got higher as it's a gas. So let's look at water. Here's water as a gas. So this is the steam. Here it is as a liquid. I want it a little bit warmer. I don't love the liquid demo in here because the liquid would take up some space over here. I want to point out a couple molecules. See these guys up here? Even though this is a liquid, you're still going to have a couple gas molecules above it. So that's because you always have a little bit of vapor above a liquid, even if it's a liquid at that temperature. Um, so that's how you can like smell hot chocolate, right? It's still a liquid, but there's a little bit of gas always above it. And then let's make it a solid. You can see they're all kind of clunked together. They're shaking in place. They're not really moving around as much. The temperature's lower. So those are just the visuals you want to look at. And if you're ever trying to solve a problem about what happens between solid, liquid, and gas, you can always look up this PhET lab. It is states of matter. So let's go over some more differences. So for a solid, the atoms or the compounds, so those molecules or formula units, whatever the state, the type of matter it is, they're barely moving. They're just kind of like sitting there, just shaking in place. They don't have that much kinetic energy. Kinetic energy is the energy of movement, so solids just kind of sit in place. In liquids, the atoms or the compound units are flowing past one another. So they're all staying in the same area, but they're just kind of like moving past one another, like swimming past one another is a way to think of it, especially since it's a liquid. For gas, atoms or compounds are moving quickly. There's so much kinetic energy. Kinetic energy is the energy of movement. So gases have the most kinetic energy. They are bouncing off one another. Their gases are traveling in a straight line, and they're just going to keep going until they hit something, which is why they take the shape of their container, right? So they're going to go until they hit the edge of that container, and then they go again until they hit the other edge. So they go from one end to the other. That's why they take the shape of whatever container they're in. And they could also collide with other molecules, right? So oxygen around you right now that you might be breathing, there's maybe one over here and one over here, and they collide, and then that makes it bounce. Because solids are moving the slowest, we say that they have low energy. And when I say energy, I'm talking about kinetic energy. Kinetic energy is the energy of movement. So liquids have middle energy, and gases are going to have the highest energy because they're moving around the fastest. Gases are like after a molecule's taken in a bunch of sugar, well, atomic sugar, it moves around really fast. Solids are always the coldest, liquids always have the middle temperature, and gases are always the hottest. So, for example, something to remember if you're forgetting that, if you ever watch like Chicago Fire or any fire show, they send all the firefighters in to get people in a fire before they hose off the building. Why do they do that? Well, if you have a fire in the building and then you spray water into it, then what does water become when you put it in a fire? It becomes water vapor, which is really, 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 really hot and takes the shape of its container, as in will fill the whole building. So before you have the fire just in one place that can burn someone, but if you have someone in a burning building and then you put water in that burning building before taking the person out, that burning building is going to fill with above boiling temperature water vapor, and the water would actually burn the people even if they're not touching the fire. So if you're like, whoa, how's the temperature? You can think about Chicago Fire and the TV show and why they send the firefighters in to get people before hosing it down is because if they hosed it down, the water would become a gas. Gases are hotter, and the gases would actually, the water that turns into gas would actually burn people. Okay. Some more facts. So solids, the atoms are close together. You can remember that they are the coldest. So when things are cold, what do they do? Stick together. The liquids, atoms have some distance between them, but not much. And if you look at this, all of these represent 25 atoms or particles. So look how close they are here. And in size, this gets a little bit bigger. And then this gets even bigger. In gases, atoms or compounds are very far apart, and how far apart they are depends on the container. So if it's in a small container, they'll only be as far apart as they can be, but you can put them in a large container because they just spread out and they take the shape of their container. So because the solids are closest together, they have the highest density. So density is saying how many neighbors are right next to you. Do you have a lot of stuff around you? If so, you have a high density. That means liquids have the middle density and gases have the lowest density. If you look at one atom and you look around, it has the least close neighbors, so it's the lowest density. There is an exception, and that is water. Water actually expands when it freezes. It's the opposite of the usual pattern, which is what makes ice less dense than water. So that's why ice floats on the water, which is really good if you think of things like glaciers. It'd be pretty bad if ice were denser than water, then glaciers would be underwater. We wouldn't know where they were. So it's a good thing ice floats, but that's the only substance that does that. So it's only the exception to the rule. In general, solids are denser than liquids, which are denser than gases. Okay, so that covers it for phases of matter. Good luck with this section. Make sure you talk to me if you have any questions, and I will see you in the next set of notes.